solving two problems in the homework. I'm going to set those up and get you started on the first couple steps. And I'm first going to look at problem number 16 on page number 93. And number 16 is a distance and bearing problem. While I read it, I'm going to set up the problem at the same time. A man wandering in the desert walks 2.3 miles in the direction south 31 degrees west. It gives a bearing, so what you want to do is drop a north-south line on the bearing and then draw in the south 31 degrees west. South means from the south part you're going 31 degrees west, therefore you're looking at this, and you're going to label it. I'm done with the first sentence. I no longer have to look at that sentence. Then he turns 90 degrees and walks 3.5 miles in the direction of north, 59 degrees west at that time. Okay, so the next part is you just want to draw that, and it gives a different bearing, which means, again, you want to drop a north-south line. And at this point, it's north 59 degrees west, so it's off the north side, it's the north end, and so this angle right here is going to be 59 degrees. And he walks for 3.5 miles. At that time, how far is he from the starting point, and what is the bearing from his starting point? I'm not done with the drawing. I want to put in my unknowns, and then I can just focus on my drawing. Couple things to be careful about. Just because it looks like this arrow finishes to the direct west doesn't mean that you have a nice line going across here. All right, you have to assume that it's not going across, and therefore you want to go ahead and figure out how far is he, what is your x, and also you want to figure out the last part, what is his bearing from his starting point. This is the starting point. The bearing from his starting point can either be two things. It can be from the top down, or it could be from the bottom up, depending upon if it's 90 degrees or less. So wherever it's less than 90, or I should say 90 degrees, less than 90 degrees. So wherever it's less than 90 degrees, that's the line that you want to write for the bearing. I don't know which one it is, but let's just assume, because it's probably going to be easier, that that is going to be my theta that I really want. And hopefully it's less than 90 degrees. If I'm wrong, I can adjust later. At this point, I have everything that I need to know. This is 90 degrees. One of the reasons why this is 90 degrees is the book says it's 90, but the other reason is because if this is 31 degrees right here, then this is 31 degrees because those are alternate interior angles. They're congruent. So you have parallel lines, you have alternate interior angles, and you're going to see that that's 31 degrees. 31 degrees plus 59 degrees is going to be 90 degrees. There is your right angle. At this point, we can write down some information. First of all, we can use the Pythagorean theorem. X squared equals 3.5 squared plus 2.3 squared. And then I can solve for x. That's going to be the distance. The second equation is going to be, well, I really need to know what alpha is to get my theta, because 31 plus alpha plus theta is 180. If I can get my alpha, I can figure out my theta. So that's where you have to work within the triangle to get ultimately what you want. Therefore, to find out what alpha is, I'm using tangent because it's opposite over adjacent. Tangent alpha is equal to 3.5 over 2.3, and therefore you do the inverse functions to solve for that. Then you could find out what your theta is equal to, and then you can write down the bearing, either off the north end or off the south end, depending on if it's less than 90. All right, that should give you an understanding in terms of 16, setting it up and approaching that problem. Be careful on the drawings. You want a nice, clear drawing. You want to put everything in there, and then you want to start solving it. Let's try looking at number 18 now. It's a distance and bearing problem. For number 18, one thing at a time, again, on this drawing. A tree on, so page number 94. A tree on one side of the river is due west of a rock on the other side of a river. So you have a river somewhere coming through, and you have a tree due west of the rock, meaning the tree is going to be located here, the rock is going to be located here, so you have a point and you have a point. Due west. First sentence is done. From a stake 21 yards north of the rock. From a stake 21 yards north. So now I know that that's going to be a right angle. You got west to north. 21 yards. The bearing of the tree is, okay, so where do I put this bearing now? From a stake, there's my key, that is my anchor, that from part. From a stake, the bearing is this to the tree, meaning this is what it's talking about. South 18.2 degrees west. Should make sense in your drawing. Now the question is, how far is it from the rock to the tree? What is your x? Now that you got that set up, that's a very simple SOHCAHTOA question. One thing at a time, drawing them very carefully. All right. Again, take your time on the drawings, and I think you're going to find this easy. If you don't take your time, it's going to be a lot more challenging. Don't have little small drawings. Blow them up. Really see what you're doing in these drawings. Whenever you see bearing, drop a north-south line.